In this video, I am going to use trig substitution to integrate dx over x squared times square root of x squared minus 1. The substitution that I am going to use is x is equal to secant of theta. X is equal to secant of theta. Then dx over d theta is going to be secant of theta. Derivative of secant of theta with respect to theta is secant of theta times tangent of theta. Then dx becomes secant of theta times tangent of theta times d theta. Now if I plug in these values into the original integral, I get integral dx is equal to secant of theta tangent of theta d theta. Then I divide it by x square, which is going to give me secant square of theta because x equal to secant theta. So secant square of theta times square root of x square secant square of theta minus 1. So let's simplify it even further. Integral secant theta tangent theta d theta divided by secant square of theta times square root of secant square of theta minus 1 is actually tangent square of theta because secant square of theta, which is equal to 1 plus tangent square of theta. Now if I solve for tangent square of theta, I get tangent square of theta is equal to secant square of theta minus 1. So I just substitute tangent square of theta instead of secant square of theta under the square root here. So that's going to give me square root of tangent square of theta. That is going to be integral secant theta tangent theta d theta, all of it divided by secant square of theta times tangent of theta. Now tangent theta they cancel out. Secant theta goes into secant square of theta, just secant theta times. So that leaves me with integral d theta over secant of theta, which by the way is integral d theta over 1 divided by cosine of theta, which is equivalent to integral cosine of theta d theta, which is nothing but sine of theta plus some arbitrary constant c. Now remember, x is actually secant theta, so theta must be equal to secant inverse of x. So I just replace that value here. If I do so, my integral becomes this, integral dx over x square times square root of x square minus 1 is gonna be equal to sine of theta, but instead of theta I'm gonna put secant inverse of x. So secant inverse of x plus some arbitrary constant c. So that should be my final answer. So integral dx over x square times square root of x square minus 1 is equal to sine of secant inverse x plus arbitrary constant c. I hope that this discussion was helpful. Thank you very much.